Yo, what's up, everybody? Welcome back. Today, we are working on convex hull generation for our code visualizer. So this is what we are working on. This is a visualization of all of the components of our image editor code base. We have walked the code base and found every folder, file, type, function, and tried to correlate those things in some way, shape, or form. The idea here is that eventually we're trying to look for some sort of relevant visualization that will help us at a glance provide information about what we're working on right now, right? So if we're spending more time in one area of the code base, we want to focus in on that. We've been experimenting with different ways to do that. Our last attempt was maybe focus by size. I'm starting to think that this isn't what I want. But the idea here is that we'll be able to show, some sort of context. And something that I feel like is missing from this graph right now is the ability to just see hierarchical groupings. So the way that the code base is laid out, there's kind of or the way that the graph is generated, there's kind of two hierarchies. One is if I'm in the file db.zig, db.zig has a struct or struct, let's see, it has a struct node it has a struct node, and in this node there's a function load, right? So you have the hierarchy of load owned by node, owned by db, owned by source, right? That's one hierarchy. The other thing that we're paying attention to though is that load uses array list, right? And so if array list was in our group, then we would want to tie those things together as well. And so what we see here is we're trying to represent both of those hierarchies spatially, which is maybe a little bit annoying because it means that it's hard to tell the difference between those things. And so what I wanted to experiment with is to see if we can show hierarchical groupings in some other way. And what I was imagining was we could maybe look up if we imagine this thing as a map of the sky, constellation, right? We could think of it that way. I thought maybe we could take some inspiration from looking up galaxies on. Do you guys want some galaxy gas? That's crazy. Galaxies. So I was imagining that we could take some inspiration if we just look up pictures, right? And we can say okay, so when you look at star maps, we might see something maybe a little like this, right? Where you have colors that are associated with different things. And we could imagine that we could make sections of the code or sections of the map kind of background colored, right? So maybe we say we take this, right? And we go oh my god, I'm going to lose my mind about that fucking search thing. Paste, hello, there we go. So we could maybe imagine that all of this stuff, that's way too big. All of this stuff gets kind of background colored in orange a little bit, or tinted or something, right? We can imagine something like this. And in order to do this, we need some way to draw this shape. And so what I wanted to look at was convex hull generation. Convex hulls are essentially, if you were to take a grouping and you're just trying to enclose them, a convex hull would look kind of like this. Right, so what kind of shape can you draw that encloses all the points in the thing you're looking at? And importantly, this is not a convex hull, right? Because this point, you can't draw from the center out to each point without crossing yourselves. So the convex just means that there's no inner angles like this. I don't really know how to formally to say it. But what my thoughts are here is if we make a convex hull, then all you have to do is you go to you can draw a triangle fan from the center to each point in your hull, right? And because of the way that the convex hull is, this is always going to work. And so you could draw a shape like this, and then we can do whatever we want, right? We can sample this shape for density near different points or something, and maybe it'll become more colored in where there are kind of more points localized in that area, something like that. I haven't really thought super hard about it, but I feel like a convex hull is a good thing to try, and if we don't like it, we can move on. So I was looking up convex hull algorithms. I didn't really get very far. I think we might do gram scan or quickhull. They both seem kind of sane. And plan of action is probably let's just set up some sort of visualization of like drawing a convex hull so we can see if it works. Then once we have like a drawing that we can make, then we can like practice actually making one with one of these algorithms, and then we can try to make it look interesting in some way, shape, or form. Yeah, let's run it. Let's just run it. 0525. Okay, let's render anything. Render a thing. So, let's go into our little viz program, and in here, somewhere, we should just render a hull. So, presumably we're going to have more than one hull, right? And presumably we're going to render them with OpenGL, the same way we render everything else. Where do we do any other rendering? In our main loop, we call circle program render, line program render. So that kind of indicates that we're probably going to want some form of like hull program, probably. Seems kind of reasonable. And the hull program is probably going to use, he's going to have like some buffer of points, right? So like in OpenGL land, what you typically do, did I lose my paint instance? In OpenGL land, what you do is you like define a set of points, you throw them onto the GPU, and then you ask the GPU to draw them in a way, right? So what we're going to do is we're going to try to define this thing as a triangle fan, like we said. So we're going to say, I'm going to define this point in the center, then this, then this, then this, then this, then this, and we'll be like, can you draw that for me, please, sir? Maybe we have to draw this point again, I'm not sure. So I guess to do that, we're going to be like, update. We're going to say update hull buffer, okay? And this is going to take the hull buff, I guess. And for now, we're just going to say that we take no arguments there because we don't really know what we're going to do. We're going to copy paste something else, update hull buffer. And for now, like we said, we have some buffer that we're working with. And we're just going to do what these guys do. So we call buff update buffer with some points. And I guess let's just start by defining some points. So I guess if we're trying to throw a screen on here, we could define like maybe we want to do what, like 5 points for now? 1, 2, 1, 2, 3, 4, 5 or something. One, and so what do these look like? This is like negative 0.50. Okay, so we'll define the center of our hull right now at 0, 0. So how do we do that? We need like some buffer points. We need some buffer points. Okay. Boom. So do we copy paste this to say here is our buffer point name. We'll make an array of these things, I guess. Okay. I think like this. Boom. And then each one of these is going to look like this. Womp, womp, womp. Cool. And I'm actually thinking about this, and the way our like OpenGL abstractions work right now, it will be easier for us to draw this a different way. Because the triangle fan thing, our like render abstraction right now doesn't really support that. He only draws sets of triangles. So is there like a way to, I guess we still do the same shape and we just specify the center point every time. Yeah. So we'll draw this triangle, then this triangle, then this triangle, and we'll just specify them each individually. And we'll put a fix me in here to come back and do a triangle fan later. Okay. So const center is going to be a buffer point of, I'm going to ignore UV coordinates right now. We can come back for those later. I'm sure that those will end up being useful. I like your style, just throw it in and see if it sticks. Yeah, there we go. Yeah, it's by design. It's by design that we're like this. So the center is just going to be 0, 0. And then our first triangle is going to be center. We have a point below the center, so this is going to be like, maybe we kind of do it like this. Clip X is going to stay at 0. Clip Y is going to be at like negative 0.5. And then we'll ignore UVX and UVY. Although, again, those will become relevant later. I'm fairly sure of it. And then let's say we do this point. So this is like kind of a little bit off to the left, a little bit down. So let's say this is like, you know, negative 0.4x and negative 0.1y or something. I don't give a shit. This is like a little bit left and a lot up. So we'll do a second triangle that goes from center to the point we just defined, and then we do a little bit up. So let's say that this is going to be like y 0.5x negative 0.2. Sure. We'll do another one that goes like positive 0.2. We'll just kind of do the same thing but mirrored. Okay. Then we need something bottom right, which I guess we'll just mirror from the bottom left one. So we start with the same point here, and then we mirror the bottom left point, which was this one, I guess. So this is going to be point positive here. And then we do one more triangle that's like, this is all points that we've already defined, right? So we just need to take the bottom point here. Boom. Okay. I don't know. Seems fine to me. We can always do something different later. Okay, which means that we're actually not using allocator here. For now. We do need a buffer to work with. So where do these like point buffs come from? We say, let's make us a circle program, a line program, and we'll make ourselves also a hull program. Okay. And what are we gonna do? We're gonna have some sort of like hull shader. For now, let's just make it simple for ourselves and color everything in white. Just to make things simple. Okay. Which means that this becomes straightforward. We need our hull buff. So this is hull prog make default buffer, defer hull buff unit, okay, to free our memory. Then we have to call hull program render with the hull buff. And then some I don't give a fuck parameters. Okay. Yeah, let's just see what happens if we do that. Found pointer. This maybe? Okay, that compiles, and let's see what happens if we do that. That's not good. I expected to see something here, and I do not. Oh, probably because I didn't compile. I only did like a little like syntax check compile, not like a real compile. We're close. We're definitely close. We missed the last triangle, maybe? 1, 2, 3. Yeah, we're missing a triangle. Why? 1, 2, 3, 4, 5 triangles. Is this one wrong? 0.2, 0.5. Oh yeah, we were supposed to use this. I think we just used one of the wrong points. There we go. That's a fucking polygon if I've ever seen one, baby. Okay, so can we now pretend that we passed in a list of points that make up the hull? Instead of what we've done here, we want to pass in the 5 points, not the 5 triangles. So let's say that we have points as just like a bunch of vec2s, okay? And we will change this to say, we'll call this triangles. like this. And then we will say, for, I guess we're gonna have to somehow calculate the center of these things. I guess it doesn't have to be the center. It just has to be like literally any point inside the inside the polygon, right? It can literally be anywhere in here as long as it's between all of the points, which means that probably we can take the center by calculating the average of these things, would be my guess. Actually, let's start, but instead of taking in points here, let's just start by kind of moving this stuff up. So we'll kind of take these points and we'll put them here, and we will just delete all of the duplicates here. Right, so I guess these are kind of our points, right? And maybe we ditch the UV coordinates as well. Maybe. So maybe we just call these like, you know, something like this. So for each of these guys, we say, comma, 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 chameleon. Okay, boom. Then here we calculate the center by iterating over the points. So we say, for points, point. We say that we have our like center x is an F32 equals 0. Center y also equals 0. And as we iterate these things, we say center x and center y is plus equals the thing. Yeah. I don't know. And then at the end, we just say like center x divide equals float from int points len question mark. So this should give us like an average, I think. Then here we say center x, center y. And then we iterate the points again. Oops. This should be find the dot, delete to the equal sign, find the dot, delete to the equal sign, go again. Nope, because there are dots in the numbers. Okay, go to forward a word, delete to the equals, go forward a word twice, delete to the equals, go again. There, that's better. That's better. Okay, so now we iterate over those points. Probably we iterate for 0 to points dot len. I think that's easier. And for each of these things, we push into some buffer. So we're going to have some sort of like array list of buffer points. Initialize with some allocator, which we don't have. We're going to take that in a second. We'll call this, you know, the triangle buff. Okay. And defer triangles deinit. Boom, bang, bang, bang. And for each of these things, we're going to take A is 1 point, which is going to be points I, right? And then B is going to be points I plus 1 percent points dot len, right? So make sure that we stay in bounds, and this will handle like the wrapping case where if we get to the last element, we wrap back to the first element. Boom. And then we just push these 3 points, right? So we say triangles append slice of these things, which is going to be center, chill. And then the first thing is going to be A0, A1, and the second thing is going to be B0, B1. Wow. Okay. So then this goes away, and we update our GPU buffer with the thing that we made on the CPU. Seems reasonable. Seems reasonable so far. Let's see what happens. First of all, are we remembering to deinit everything? Yep. Okay, this thing can fail now, which it already had a try on it, so we're chilling. Let's see what happens. All right, we still have the same polygon, which is very good. And that means that now we should be able to actually take these points and pass them in externally. So we should be able to say, like, points is, you know, vec2. This comes from here now. We'll call this hull points, just to be a little bit clearer. And then we pass hull points in here. Okay, make sure that everything is still good. Boom, everything's still good. And we just try adjusting some of these points a little bit just to make sure that, like, you know, like we can see some sort of like we see the thing that we're doing taking effect. Yep, so that's a different polygon, still great. Everyone's happy. So, dummy hull render. Boom. Maybe it makes sense to draw the hull underneath everything else, because and in a different color, because that will give us a clue if the hull generation is working correctly once we start actually working on it. So where are our shaders? So for now, let's just kind of draw this in like a gray, maybe. Hey, what are you creating? Map. We're mapping code bases. Mapping code bases. Okay, sick. Sick. Looks like that is working. So now the question is how do we wrap one segment of points in this? So let's try to like pick some area of the code base and see if we can like yeah, well, let's just pick one area and see if we can identify it. Now, we kind of broke the find node under cursor, which makes this a little bit of a pain in the ass. But we can probably take some guesses about like where some of this stuff is. Can we look at like maybe the GUI framework? And can we look at like maybe something like label? Like GUI label label. Okay, so like where's this? Okay, that's fuck. Right here, that's the GUI label. What about like something like out here? Maybe something more like math stuff. I expect to be. Do I expect that to be on the outside? What do I expect to be on the outside? I don't know. Okay, math. We'll try to do all of the math library. Let's do that. And before we do that, we can probably try like coloring that section in a different color. So maybe we could say like for each point in the database, sure. For now. Let's see. Graph database ID iter. Okay. We'll iterate every node in the database. And we'll check if it is related to the math repo, the math stuff. So we can say like if the name starts with that, which was like source math, I think was what we were looking at. We can quickly check that again. And then we will put that in a buffer. So we'll say like we'll call this like math points is going to be like whatever this shit wants. Oh, that's annoying. Oh, that's kind of annoying. This is not a type that it makes this easy to work with. Okay, we're just gonna copy paste this, and we'll say like update. I don't know. Update points. Update like highlighted points maybe. Because then we can say that this is going to be an array of these things. We'll ignore the weights for now. Okay, that's fine. So then we go like for positions, position. Okay, that should make our lives a little easier. Fuck weights. So this is going to be like this, and then everything else is kind of just the same. Okay, cool. So wherever the fuck we were now, we can go like array list of vec2s. Initialize their allocator. Boom. Defer dnet that thing. if it starts with math, we add that to the math points. So I think we have positions in here. Positions get at this node ID. Okay. Yes, yes, yes. Okay, chill. And then we call like update highlighted points for all of these things. Okay. Yup. So we use our allocator, we use math points. And was that it? As well as default circle radius. Okay. Okay, and then we render these again. And then hopefully we can render these in a different color and see some sort of like indication that there are in fact math points. What's he pissed about? Allocator buffer, true. All right, what's that do? Okay. So we see math points over here, which is a good sign. They do seem to be somewhat close together. And hopefully we can draw a little box around them and see what happens. You know, maybe our selection is a little bit too big, but that's okay. That's okay. We can always come back and kind of narrow in. Maybe we won't like the idea of a convex hull here anyways, but we should try it. We should try it. So let's try to group these math points in some way. Let's look up where did I have another window for this? Okay. What do we like the idea of here? GramScan or quickhull were the two that kind of jumped out at me as like pretty easy to implement. So GramScan kind of seems to like walk points in some way, and like as he kind of iterates through them, he kind of like notices like, oh shit, like there's a better point than the one I've looked at. So I think he kind of like walks. He must walk backwards until what? Like until there's no like concave sections? Not sure. What? Okay, 4 points. Find lowest y coordinate and leftmost point. Sort points by polar angle with p0. Okay, that makes sense. For all points, pop the last point from the stack. While the stack is greater than 1, and one thing is like counterclockwise from another thing, pop the stack. I see. So we say like we are walking here, we're like walking counterclockwise. We're walking counterclockwise, yeah. And he just iterates each point and he says like, yo, if this thing's like more counterclockwise than the other thing, then like I'll take that one. Okay, that makes sense. What about quickhull? What are they doing? I think I saw a picture here. Yeah, here. He's kind of like seems to be like iteratively snapping extra points in there. So I think that he's like starting with some triangle and then he just keeps expanding the triangle in some way. And this is supposedly like best case n log n, worst case n squared, where the GramScan was like guaranteed to be n log n, except for the part where we have to pre-sort probably on all of these would be my guess. I don't know, like I would imagine that in order to do this GramScan, maybe not. Maybe he's just hitting every point exactly once. Yeah, maybe he is. Maybe the order of iteration here doesn't matter. I mean, it must, right? Because this point has to come right before this point. So how is he determining like order here? Sorting the points has time complexity n log n. While it may seem that the time complexity of the loop is n squared, for each point it goes back to check if any of the previous points makes a return. It's actually O n because each point is considered at most twice in some sense. Each point can only appear once in the left term because the algorithm will advance at the point after that. So where's like the sorting? Okay, the first step is to find the point with the lowest y coordinate. If the lowest y coordinate exists in more than one point in the set, then we sort by x, sure. So this is ON, right? Because we have to look over every single point. Next, the set of points that must be sorted in increasing order. Next, the set of point must be sorted in increasing order of angle. N log n. Sorting order of the angle does not require computing the angle. It is possible to use any function of the angle which is monotonic in the interval 0 to pi. So we can dot product. Sure. If several points are of the same angle, break ties. Okay. So we don't have to sort to do this. So what about for like quickhull? Do we have to like pre-sort? Divide and conquer. Worst case for 2-dimensional, 3-dimensional is O(n) squared, but the input precision is restricted to O log n bits. Its worst case is conjectured to be this, blah, blah, blah. Okay. So what do? They find the points of the minimum, maximum x coordinates, as these will always be part of the convex hull. That makes sense, yep. If many points with the same minimum and maximum x exist, use the ones with the minimum, maximum y respectively, sure. Use the line formed by the 2 points to divide the set into 2 subsets of points, which will be processed recursively. We next describe how to determine the part of the hull above the line and the part below. Determine distance, maximum distance from the line. Ah, interesting. So how do you do this? You have to do like, give me like a line. Okay. God damn it. Every time, dude. This is like, you have some line. Oh my god, that's stupid. Some line. And you have like point like here, 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 here. Are we trying to find like maximize this distance? Is that what they're saying? Yeah, it must be, right? They're trying to find like the maximum perpendicular distance, which is probably dot productable in some way, right? Because you have like, you draw like this line and project one onto the other. No, that gives you this. How do you get this? You do like, I mean, you just draw it. I mean, I guess if you have this, then you can easily get this. Is that how you do this though? Or is this like a cross product? How do you find like distance from line? Vector projection proof. Okay. So, oh yeah, I guess we have the normal. So we have this. And so you can do the projection from this onto that. Sure, that's pretty straightforward. Yeah, that's pretty easy. That's pretty easy. Okay. Dot product of the cosine of the angle, cross product of the sine. Oh yeah, so I guess you could just do cross product instead, and that would give you the same thing, right? You would get like, which is essentially what you're doing when you do this. You turn the like x, you swap the x and y and turn one negative, which turns it from the dot product to the cross product, kind of like implicitly. Yeah. Okay, sure. So pretty straightforward. Pretty straightforward. So we go back to this. So we find the thing with the maximum distance, which we can just cross product. Sure. Points lying inside that triangle cannot be part of the convex hull, and therefore can be ignored in the next steps. Okay. So how do we determine if a point is inside a triangle? Recursively repeat the previous 2 steps on the 2 lines formed by the new sides of the triangle. Okay, so here, you must have to like pick a direction, right? Like, Surely you don't want to go down to the left on this top right line. Surely. Okay. Which I guess means that if you're only going outwards, then you like implicitly just discard any magnitudes that like any cross products that are negative, probably. I think that makes sense. So, oh, in fact, they only do above to start. So you probably just go one way, then depending on like if you're going clockwise or counterclockwise, you just discard all negative or positive negative numbers or something. Yeah. Okay. And then do they have some sort of like intelligent way to like pre-select elements that are outside like how do they like efficiently bisect the set of numbers that you actually look at for the recursive step? Pseudocode. Okay, what do they do? Find the left and right segments. Okay. Find hull S1, find hull S2. Ah. So when you walk each thing, you like split those into sets of things that are above or below the line, and then that makes your whole life easier. Yeah, okay. I'm down to do that. That seems pretty reasonable. That seems pretty reasonable. Sometime before now, we were definitely started working at this. We can say like we can call this like pick a hull algo, and then we will say that now we are implementing implement quickhull. This seems reasonable. 2D cross product doesn't really exist, but I guess the proper term is wedge product, but that's mathematical nitpicking. Yeah, I just consider like the arrow coming into my face and then discard the component. I'm like, that's kind of like a cross product. Like, close enough. Okay. So let's take this set of math points and turn them into a hull. So let's say we take this, stick it here, the hull render points, and then we say what? Like find hull for the points that we pass in, and probably with some allocator would be my guess here. And then we use the hull points probably directly like this, sure. Okay. Find hull. Takes an allocator. That's the points. And actually, if we wanted to get really clever with this, we could do it iteratively. We could make it so that we can like run the iterations interactively so that we can like easily debug if we fuck it up. But there's also a chance that we one-shot it, in which case that extra work is not necessary. So maybe we start by just no, I kind of like structuring the code that way anyways. Fuck it. Okay, so let's do something that's like hull finder. And here we're going to have some sort of like function step, right? And I guess this guy, this is like a recursive version of the function. I don't really want to do recursive version of the function. So what is he effectively doing? He's saying like I'm constructing a tree. Is it a tree? Yeah, because each each iteration of find hull is spitting out 2 more find hulls. Right, so we're kind of doing like, I guess, like a depth first search in some way. So this is like kind of using like the stack as a data storage mechanism. We can just put that stack here. So we can say, let me think for a second. I guess we're going to call this like point sets. Yeah, point sets. Which is going to be probably an array list of like, I guess you can kind of do it like this. So you could have like a bunch of points that you have kind of just here. And I guess you're kind of like sorting them as you go, right? The reason this is called quickhull is because it's very analogous to quicksort, right? And so what are we doing? We're like iteratively splitting this into things that are above and below some line, right? So probably we can say that we have like splits. I think. And so what we can do is on each iteration, we can like basically bucket these things at some partition point. And then I guess we can kind of call it like the split point. Okay. And so then we say like everything above the line is everything before the split point is above the line and everything after is below. And then what? As we go, we like create like a stack of these hull finders. Is that how this works? So at each iteration, we make a new hull finder that has split points. And then at some point, we have to do something. I haven't quite got there yet. So let's just start with the first iteration, and we'll find out where we end up after that. So I guess on the first iteration, we're going to pass in a list of points. Right, like this. These aren't U8s, these are vec2s. These are points, right? Okay. And we are going to partition these in some ways, right? So that's kind of this part. Find the left and rightmost points. And then how do we tie break again? We tie break with left side being lowest and right side being highest or something. Okay. So we go like, we must have some sort of like, I wonder if we can like partition. If there's a partition thing in this language, that makes our lives really easy. Well, first we need to iterate. We definitely have to iterate all the points once to find the leftmost and rightmost. Okay. So, 4 points. Point. Leftmost point is going to start as what, like a vec2 of inf, right? And the rightmost is going to be negative inf. I think. I don't know. Might be able to use partition point or lower bound. That seems. I think lower bound. Both of those are expecting sorted vectors already, though. I think. Zig standard lib. I think I'm actually looking for like min and max. Probably is what I'm gonna end up with. because my input is not sorted, I think. Right? I'm assuming that this is like, yeah, I'm pretty sure that for one partition point to be at some predicate, you need to have them be bisected by that thing, which we don't necessarily have yet. So we'll figure that out. Okay, so for points, we're going to say if point dot x is less than, or I guess it's point 0 is less than left 0, we say left equals point. If right 0 is greater than, if point is greater than right, this is now the new right point. And then we have to tie break. So else if point 0 is equal to right 0, and point 1 is greater than right 1, because here we want to use negative infinities for right and positive for left, then we say right equals point, and then we do the same thing here. Else if point 0 is equal to left 0 and point 1 is less than left 1. There we go. And so I guess these don't have to be else ifs. These can be folded down. So we can say or this. And we kind of do the same thing here. Okay. Okay, so now we have our left and right point. And then we have to do some sort of like bisect, right? So something about like partitioning does still seem reasonable, right? Like I know that in like C++ there's stood partition, I think, which lets you basically like say, given some predicate, we make it so that everything where the thing is true becomes before everything which is false, right? So is that like a thing that they have in here? I wonder if just like doing like an unstable sort is kind of like the same thing. How the fuck? I guess like we want to, like, I guess this is what quicksort does, right? Is that what quicksort is? Give me the picture. Yeah, that's exactly what we're trying to do, right? We're trying to like recursively partition these things into above and below. So I guess what they're doing is they're comparing it's been a while. It's been a while. So what's happening here? Let's look at the picture again. They take the outside, the whoa, what is happening? Oh, I see. He's taking a partition point from the center. He's taking like a partition point from the outside and continually just like keep swapping that into the spot where it makes sense. Oh, I don't want to do this myself. I was kind of hoping that I didn't have to. Dun 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 dun. Well, I've never seen this. It's interesting. Okay. So we say, what do we want? We have some line, right? We want to iterate all points and bucket them as above or below line, right? That's what we're trying to do. And so if we don't know how many of each there are, right? So we need some way that as we iterate this thing, we can dynamically update like the split location. Right? That makes sense. So let's assume that we want like everything above line goes to the right side and everything below line goes to the left side, right? That's kind of what we're looking for. So to do that, I guess that we have like two indexes, right? We have like the below end and the above start, right? Var below end is equal to 0, and the above start is equal to the number of points, right? Then, just as we iterate points, we say for points, maybe it's easier to do this in a while loop in some way. So we say like we have some like index. While I is less than above start, we look at the points I, right? And we categorize this thing. So we say like is above. So we look at the points as well as the left and the right, right? Then, if this is true, what do we do here? We set like below end is equal to I think. Otherwise, we need to put this thing in the current above start slot. So we say like above start minus equals 1, and we swap this element to that position, maybe? Right? Yeah, that sounds right. I don't know. That seems reasonable, right? Yeah. And then in this case, now the new point, we just look at the same index again, I. And so here we say I plus equals 1. Because there was no, this is guys good to go. And does that sort things? Because then eventually, for each point, it either has to be above or the below line. It has to be. It's one of the two. And so for each point, we can categorize it without having to look ahead or behind. And then eventually, we'll hit above start. It has to happen. So then we can do like below end should be equal to above start, maybe plus 1 here. Is that the expected case here? Because no, they should be equal. They should be equal, right? And then we just set the split point to that. Sure. That seems reasonable. And then we just have to recursively do that. Right? Right? I don't know. Don't pretend I know what's going on. It's now we just have to implement is above. Okay. So I don't know yet. So we said we're gonna take 3 points, right? Point, and then like left and right. Okay. And I forgot, we also wanted to keep the maximum, we wanted to keep the maximum point as well. So I think that actually we want to do, I think we can just do like dist. I think we can just do a cross product in 2 dimensions, like we said. And so here we have 3 points. So if we are we're trying to do, I don't know, A, B, C, right? AB is our line. So we want AC as our other thing. So we want to do, I'm sure the order here matters, but probably the order here matters only that it has to be consistent. So I don't actually care which one comes in here first, as long as we do it the same way every time. So we do just right minus left over points I minus left. And then here we say if dist is less than 0, we do this. And then we need to find, like, we said we need to find, like, the thing that was farthest, right, the biggest number. So biggest point, biggest dist, largest dist here, and then the, like, farthest point is going to be start as 0 probably, and then here we'll say, like, if if largest dist is less than dist, we set the largest dist to dist and the farthest point to I. Yeah, and then we can, like, stash the largest distance here. Sure. Maybe. I don't fucking know. That seems like a reasonable place to start. Let's see if this does what we need it to do, which is partition a section of points such that everything above is one thing and everything below is one thing. So we should be able to, like, sorry, I'm thinking. We should be able to just run this shit. We should just be able to, like, initialize this thing. Hull finder init, right? With our math points. Right? And we say, fuck it. You can reorganize these things. I don't give a shit if you reorder them. Okay. Then I guess we don't have hull points yet, but we can update the highlighted points and draw them twice. So we can draw everything above in one color and everything below in another color. That seems reasonable to me, right? So we can do, like, HF hull finder points. Okay. We can do hull finder points. Hello? Is this thing think he can fail or something? Oh, he returns void. That would do it. So let's look at the points from 0 to split, and the points from split onwards, right? Okay. Oops, wrong thing. Fuck. So this is the other way. This is these guys need to look like this. Healthy, and these guys go, okay. Oops. Okay. Does that compile? Fuck. Expected array of this found that because I put an ampersand here when I didn't need to. Okay. Fuck. Below end. This is a U size. This is a F32. This is U size. Okay. Var I also has to be U size. Okay. And then points above start needs a little ampersand on him to say, I want the address of that thing. Missing field stack. So we just don't initialize this for now. Okay. Now he's pissed at this assertion failure. So can we, at the very least, hit the debugger on this thing? Let's see what happens. Okay. So can we see below end? Okay, fine. Backtrace. We want to be at frame 7. Let's see. P below end. P above start. So they're close. Okay. We made it close. We made it close. We didn't drive it all the way home. Why is that? I think this has to be less than or equal to. That's kind of my guess here. Without thinking too hard about it. That seems to have done it. Okay. So now the question is do we think that this has done the right thing? I think yes. This yellow point here is a little sus. Down here. But the rest seem to be kind of right? So we've taken leftmost and rightmost point. What is with this yellow point down here? That's the only concerning thing here. I wonder if there's some form of like instability in the render that we're not seeing. It could be that like this thing is like flip-flopping between two states, and so it like looks yellow in the wrong spot or something. It could also be that we have set the split position incorrectly. It could be that this split is off by 1. All right, could be. He's mad. Okay. Could maybe the other way. No, there's still something wrong here. There is still something wrong. So, okay, let's look at this again. Let's look at this again. I think it's just that we have, like, we're off by 1 on the bucketing. So, let's see. If the distance is less than 0, we say below end equals I. So this is inclusive, is what we were saying here. We were saying that the below end includes that thing. So I kind of want to say +1 here. Or do the increment first. Okay, yeah, that seems right to me. Now we're saying that the below end is 1 pass, which makes sense, and the above start is inclusive. So now that assertion should pass even though we're at stay under. Here's where I. And that seems to look maybe right to me. I don't know if you guys can see it very well because it's kind of small, but here it looks like we have a line drawn like here, right? And everything below is blue and everything above is yellow, right? So I think that's kind of looking good. I think we should probably increase the point size for this just so that it's easier to see. So where is that? Default point size. Circle radius here. Point radius here. Let's just kind of double it or something. Just so that it's easier to look at. Yeah, I would argue that that's correct. I would argue that's correct. Right, he's taking the far left, far right, and put everything below him is blue, everything above him is yellow. Sure. Now, what is next? We need to do some form of like recursion here, right? So we have now effectively bucketed these things. And yeah, let's look at the algorithm again. So once we bucket the things below or above the line, we must probably take, I assume that we take the triangle with that line. I assume that we do something like fuck off, fuck off, fuck off. It doesn't wait. I assume that we do like, like we must take like this point or something, right? Draw this triangle, right? Like probably this triangle, right? I think with some things might get excluded, like this point. And then I think that we look for points to push this line out and this line out. Right? Is that it? Like if we look at the picture, that kind of lines up with this, right? He splits the triangle and then he keeps pushing the boundaries out as he goes down. Until there are 0 points that are above the line. Yes. Yes. Okay. That makes sense. Okay, so how do we do that? Surely this logic is necessary to be split out somewhere? Okay, let's think. We must have a stack of lines to process. Yeah, okay. So I think we're going to have... Let's think. So I don't know if this idea of bisecting points recursively is correct. It must be, because we're taking this... We are recursively splitting these guys. Yes, okay. So we say, here is my line. Find me the point that expands, that is the third point in my triangle. That's what this is doing. So he's saying, find me the point that is the third point in my triangle and bisect my set. Right? That's the output of this thing. So let's do that. So we're gonna say like, we'll call this like, category, like step. I don't want to use step because step is what I want to use like externally to push this thing. So like process side. Process set. Sure. So we have like points, which is going to be a modifiable set of vec2. Yep. Then we have A and B, the like points in the line that we're bisecting with. And this returns processed set is going to have like the split point, right? As well as the maximum, the farthest point. Yes. Which lets us do all of this stuff down here. Do you find yourself having to use C functions at all because of missing functions? I mean, like, sometimes you use libraries to do that. Sometimes. I was able to segfault client compiler all because I was trying to pass in an image with a mat 4x4 as color. That's kind of funny. Good job. We have to be careful here. Because the farthest point here, we store his index, but the index could move, right? Because we're swapping points around here. So we have to be careful about this. So for now, I'm just gonna go 4 points like this. I'm just gonna do it again. Because I don't want to think about it. But we're gonna have to put a fix me here to fold it back in. Fix me should no, we'll do it in part of the previous loop. We have to. We're calculating the distance already. We don't want to calculate the distance twice. That's fucking stupid. Not clang, slang. Oh, interesting. I thought you typoed. I just assumed. Okay, so how do we track this? I guess here we just say if farthest point is equal to I, farthest point now equals above start. And then I think that fixes it. And then we have to do this tracking before the shuffling. And then I think that makes it work. I think. I don't know, man. Who fucking cares? Okay. Split point is going to be below end. And the farthest point is going to be farthest point. Which means that here we can replace all of this with that new function. So we're going to say processed set is process set, given points left and right. And then we just take this and we say processed set split point and process set farthest. Okay. Okay, so now we have to we have to do this recursively, right? So on each iteration, I guess let's make sure that it still looks right, because we don't want to accidentally break something. And that does seem like it is still working to me. To me, it looks like all the yellow stuff is above and blue stuff is below, which seems good to me. Okay. So now let's do our fucking step. Okay. So we're gonna have some sort of stack here. Is that true? Of split points, maybe? I think that makes sense. So as we walk down this split stack, we are going to store the points where we have iterating to do. No, we need line segments in here, I think. Does that make sense? Stack elem. I think we need the left and right side that we're splitting with, right? We need the line that we are using to split with, as well as the segment of the points buffer that this thing is related to, right? So we need start and end. Because we are recursively segmenting points as we go down, right? And so then we start with a stack element that has left and right that we calculate here, and point start and points end as the entire buffer. Okay. So we can kind of remove this first iteration here, and instead we'll kind of store this as like the first part of the first element in the stack. Maybe. So we'll say that we have like, you know, stack elem. This seems reasonable to me so far. Okay. So this gets I don't know. Left is equal to left. Right is equal to right. Points start is equal to 0. Points end is equal to points left. Yup. Yup. Then stack is equal to stack. Boom. Okay. So now on our first step, we just say self stack pop or null. And if this thing is null, we say we're done. If this thing is empty, we're good. Otherwise, we have an item, right? And we first process this set, right? Given points from the start to the end. And using its left and right. Okay. Yep. New, we'll call this processed. Then we append two things to the stack. So we take the split point and the farthest point. Okay, so we have our like processed farthest point. This is the new left and right side, right? We have like a triangle that we've drawn. We're segmenting over this line. And then we have this point as we've determined is the farthest point. And we have, so we say, given that, given this, I have this line to process now and this line to process now. Okay. So new point, I guess, is self points at that location. Actually, it's the set is going to be this stuff, right? Because we have to work relative to that. Okay. Then what? Then the new point is set at that index. Yup. And I actually think I've changed my mind here. This goes here. That makes all of this way easier. So then this guy gets points equals points here. Oh, yeah, baby. That feels good. Okay, so now we literally don't have this. We just have like process item points, and then we have items point split here. So we have like S1 is item points from 0 to processed split point, right? And we have S2 is the points from the split point onward. Oh, yeah. And then we just push these two sets onto the stack. Oh, it's perfect. It's perfect. That's sick. So we say self stack append. And we have the S1 is we have to make sure that we have the right set. So S1 is below, which is things where the distance was less than 0. Hold on. Yeah. So we say we have farthest point here. I think that we could do like both of these at once. We could bisect kind of like both directions at the same time. But I think that's not what the algorithm says to do. So I'm not going to do that for now. I think that there's probably some sort of double processing. Maybe? Yeah, there's something a little hairy there. I'm not entirely sure. But for set 1, everything is below the line. So S2 is everything that's above the line, which means that above the line is the stuff we care about. So we append stack points from this set. And we say process these with the left of the previous left and the right as the new point. Yes. And then push the second stack, which is right to new point to the old right. I think that makes sense. Now somehow S1 isn't used, which means that we probably need a third thing here, which is literally do the same thing we were doing before, but with left and right swapped, so that above is now below. I think that's right. Let's look at this, what they do again. So they say, for each step here, we don't have our exit conditions. Add C from each, for the given set of points in SK, find the first point array, say C, from the segment PQ. Add point C to the convex hull. So this always has to go in the convex hull. Okay, so at the end, we have hull points. This is our output. And so this thing has to go in the array. Now we have to be careful probably about order that things go into the hull point array. Probably. Because to draw them, we kind of want them in like clockwise order or counterclockwise order. Probably. I wonder if it matters. Yeah, it probably does. Because if we're trying to draw the thing, I think that like if we have a set of arbitrary points, like if you drew this this triangle and then you drew like this triangle and then like this triangle, you're not going to get like the right thing. You need them to be sorted this way so that you get all these outside lines. So probably that means that like the insertion of thing into the points is important, but they don't seem to talk about that here. Which means that their drawing probably just does the sorting after or something. Okay, that's fine. We should be able to determine the order though. Not sure. We also need our exit condition here. So they say if there is no point, right? So if S2. Also, I'm not sure I agree with this idea that we should always be putting set 1 in here. Because in this scenario where we're like point, and we are processing like this triangle, this stuff is intentionally irrelevant, right? Because it's already part of the hull. So we actually only do this first double append on initialization. That's like a one-time thing, I think. Yeah. Because each iteration should be adding 2 things. So I guess that means that off rip, we have to process the set once here on start. Okay. No, we don't. We just append twice here with right and left swapped. That makes sense. Yep, that makes sense. That makes sense. So, okay, so then S1 is completely ignored. We don't give a fuck about S1. So we only care about S2. Okay, seems reasonable. That's a maybe. That's a maybe. Okay, so how can we now visualize if this thing is doing what we want? Oh yeah, sorry. First of all, we need to say if wait, hold on. Something about this doesn't feel right still. So we have this line and we're processing all points above. Oh yeah, that's fine. That's fine. Yeah. So we have all of these points. Then we process this line and we take these points. We have this line, we take these points, and then all of these guys get discarded. Yes. Okay. So then we say if S2 if processed split point is equal to item points len, we just return true. Yes, and here we return true at the bottom. So that means that now we'll just say, okay, this branch of the tree is gone. The branch of the stack, whatever, this component, this section is done. Go your own way back up. And then we just have to make sure that we put this point in the list of hull points. And the question here is, it looks to me like we're going depth first, right? So we're kind of like, we start here, then we go here, then we go like here, then we go here, then we go here. And then as we go back up, we have to like go here now. So there's probably some way to leverage this pattern to figure out where to insert this thing. But for now, I think I'm just going to put the hull points in here without thinking about it, and we can figure out how to draw them later. So what I want to do now is I want to take the hull points out of this thing, and I want to draw them in a different color. So we can use kind of like something like this. And now, how do we want to like draw the splits here? How do we want to draw the splits? Because now we don't have just like 2 sections to draw. We have like n arbitrary sections to draw. I guess we'll just draw the last part of the stack. Yeah, we can just draw one segment of the stack there. And figure it out from there. So we can say like, I think we want to put this hull finder. Fuck. So if we're going to do this every frame, we need to run this until maybe we put in the GUI how many steps of the hull finder are we going to run? Yeah. So we can say for 0 to like num hull finder steps, we'll call try hf.step, and if this says we're done, if this says we're done, break. Yeah. And then we just need a num hf steps that we put in the GUI somewhere. Okay. So where is our like fucking GUI shit? Up here. So we say I think that this is weirdly easier if this is an F32, which is kind of funny. I think. Maybe not. Okay, so we have to like add to this property list. So let's do like add int. Add int. And here we have some sort of integer thing. And we just have to be a little careful here. This make drag gen thing. Make drag float. So elem here, add. Maybe this isn't what I want. I see. He's taking the address of an F32 here. We can do num hf steps. It just is easier if this is an F32. Because then we can just say that we have like num hf steps here. And this thing is just kind of expecting an F32. So we can do this. And we can say change num steps. And then we can just go to wherever we do change num steps. And then when we apply it, then we just like round it. Or maybe floor it. So we do like floor F or something. Which means that when we use the number of steps, we need to do something that's like int from float. Okay. Time to add an integer input or spinner to something to the GUI lib now. Ah, fuck it. Floats are like integers in a lot of ways. And then we need to de-init this thing. Which is just like self-stack de-init, probably. Okay. This thing is pissed because what? He is like, usize do not support item access. Oh, what the fuck? Oh, yeah. I didn't write stack elem here. Oops. Okay, split point found usize 774. Split point is a usize. True. We do need to actually get the point of that thing. Arrow union is ignored on these stack appends. Boom, boom. Okay. New point is not existent. Yeah, I don't know why I did that. Left is new point, right is right. Left is left, right is new point. Okay. And then HF points doesn't exist, wherever the fuck we're trying to use that. So here we're going to use if stack points, if HF stack last or null, last. If we have a last points, then we can do this. Okay. And then we draw the hull points as well on top. Okay. And then we have a 749. He's pissed because what? This guy can't fail. Sure. Sure. Allocations can fail. That's a good point. Missing field hull points at 761. Am I? Oh, yeah. That's true. Vec2 hull points, boom, boom, and then hull points equal hull points. And then here we clearly have to destroy the hull points. Okay. And that compiles. Let's see how lucky we are. How lucky are we? Okay. So num hf steps here is 1. Can I make it 2 now? I would argue that this is not working. That's what I would argue now. So let's be careful here. First of all, what colors are we using here? Let's do yellow for things that are in the fucking segment we're looking at. Let's make sure that we say that if num hf steps is less than 0, continue. Or no, we say num hf steps equals 0, like this. And then we also need to make sure that we draw all of the other points as well. So we want to first render the entire point buffer in one color. So we'll say we'll render all the points we care about in the math section as yellow. Then we'll color the ones in the segment we're looking at purple, and then we'll color the ones on the edge blue, cyan. Okay. So this is literally just like math points items like this. Okay. Okay, here we go. So blue, it thinks is a hull point. It's kind of confusing because there's some jitter going on here. Now let's kind of go back to 0 steps. So 0 steps, we have just literally everything. We go 1 step. Now we have a hull point here, which arguably is wrong. Okay, and then let's try to like get into a 2nd step. I wanna... So now just everything is yellow. What did we say yellow is again? This is RG, so yellow is everything. Purple is the part we're looking at. Okay. What if we just run it to completion? Let's kind of fuck everything else. Let's just see if we at least get edge points that look kind of sane. It doesn't look like it ever finishes, which is a little concerning. So we always pop an item off the stack. I wonder if like we're doing something wrong with this like farthest point calculation. So we're saying like oops. If the distance is greater than or equal to 0, okay. Here, if the largest distance is less than distance, okay, then we set the largest distance to distance and we change the farthest point to I. This farthest point tracking could definitely be wrong. If the distance is less than 0, I plus equals 1. Okay, so this shouldn't affect this because distance should always be greater than largest distance, and largest distance starts at 0. Okay. Then we're in above start, and we say, okay, we're going to move this point around, and if the farthest point is I, point is above start, we could make it so that the farthest point is a vec2 here. That kind of makes things simpler for us, because then we just literally have to use largest distance here. I don't think that it actually matters. I don't think we're actually using the farthest point as an index. So that might simplify some room for mistakes. Oh, we do need to keep the point though. So var farthest point. So we can just kind of do this, right? Farthest point is equal to points I, probably. Points, okay. And then here we use farthest point here. Okay, let's try that. That's also not completing. So it'd be kind of interesting to know why. Jesus Christ. Okay, so we are definitely just like cranking things into the stack. Which means that this must not be getting hit. Which is kind of interesting. Right, we're never hitting our exit condition here. So can we literally just step one time, or maybe we'll just breakpoint in here and kind of see what happens. Right, if we're like break here, okay, run it. Okay, so let's see what we got here. We got the split point is 13. Self stack here. Items pointer 0 has a length of 24. So we're bisecting this thing with 24 points, okay? So then we go next iteration. Our next iteration, we have 3 things in the stack. That makes sense because we have the bottom half of the triangle process as well as like the top 2 segments. Can we look at now what's in like in here? So we have this thing is length 11. This thing is also length 11. Right, because we're literally just saying, like, look at these 2 new line segments with the same points in them. And now we should see that on the next iteration, he should have, like, reduced the number of elements that he's looking at, right? So here we expect to see 4 things in the stack now, I think. Yep, okay. And if we look at the thing at the end of the stack here, he's gone down to length 4. Okay, so that's good. Let's hit continue a few more times. And just see what's in this thing. Okay, so there's like 11 things in here now. So what's at the back here? We have an invalid pointer. Okay, so whatever is causing this is a bug. We also have left equals right here, which isn't good. So we're hitting some edge case where like we're just doing some brain dead shit. Okay, so like points coming in here. It's just like fucking broken. Interesting. Interesting. So somewhere we are just like hucking some invalid memory around. I think there was an undefined somewhere in here. There is this. So I think there's something that were like, if we're supposed to exit here if the length is 0. Is this happening ever? And then there's... I guess there's also a case here where like there are no points in the... No, yeah, there's no points in the set. I don't understand... Okay, let's look at this again. Let's try to figure out where things are going badly. Because I obviously am missing something. So let's look at self items stack, sorry. Okay. Len at pointer 5. Okay, so this is broken. 4, totally reasonable, okay? So this really looks like it's like at the edge case we are fucking up. So I guess let's rerun again and try to find a case. Okay, so this is the broken case, right? So we go here, we have item points, or oh, here it's already broken as well. Oh, yeah, well, no, this looks okay, actually. Oh, we might have been confused because we might have to step 1 line into the function before the fucking thing is valid. Okay, we have to be careful about that. Can we just see, like, what this looks like at the end of the loop? Okay. So here we're saying there's still some stuff in here. I wonder if we're supposed to exclude the edge points from the set. I wonder if that's causing problems. Oh, I hit something. Right? It's likely that the I bet you that the edge points are recursively always part of the set. And we just have to change this to like less than or equal to. Because that will make it so that the points that are on the line, the literal A and B points, do not get included, or those will get pushed into the below section instead of the above section. And hopefully things kind of behave better. There's floating point imprecision as well. So can we do like, just say if they're below some number, some epsilon. Okay. That's looking better. Then we're saying like, okay, we tried to use the split point, but the split point might be the last point. Why are we even appending this to the hull points? Shouldn't this be this? That seems way more reasonable. And then here we should also initialize the hull points at the left and right. Okay. That might be a little bit more reasonable. It looks like we're like hitting an exit condition now, which is good. Okay, yeah. So if we were to look at the blue points as the hull points, that looks to be a convex hull to me, right? If we were to play connect the dots on those, just play a little quick connect the dots with the line tool. Maybe a thicker line, thinner line. That looks like that's fucking containing the points, baby. Let's fucking go. Okay, so let's just try to double check. Let's try to double check like the process. Let's check the individual steps of this thing. So we'll do it like this. We will do it like this. So now we should have hull points above and below, or hull points should be blue. So we've got 3 hull points right here at the beginning, right? 1, 2, 3. We have points that we care about. We have yellow is like things that we aren't processing right now. Purple is things that we are processing. So as we go down the stack, we should see the purple section shrink and the number of blue dots go up. So I would like to end up at 2 now. Okay, yep. So now we're looking at these purple dots here. Okay, now this purple dot. And now we should probably look at the other half. Maybe? Or maybe it's done. Oh no, here we go. There seems to be some steps that don't count. Like, why is this no points? Oh, it's because like in some cases we're actually hitting the case where there's no points in the set or something. I'm not sure. There's something weird there. Something about that doesn't feel right. It feels like there should always be items in the set. I guess probably we are pushing things in that have a 0 length, and we should also be discarding those. Is that true? No, we are never pushing a thing that's full. We're never pushing an empty item because of this. Right? Yeah. Oh, I guess, does this split point need to exist? Oh yeah, it's here. Yeah, because split point is the thing that defines S2. Yeah, so what's the problem here? Huh. I don't really think I understand why sometimes it looks like there's 0 things there. And then also, it feels like it's really hard to move that fucking slider. So who... Can we, like, up the speed of this thing? Just for now. Like, what am I missing here where... Okay. Oh, maybe they're just kind of hidden. Yeah, okay. So they're maybe it's because the points are being drawn on top of each other. Okay, so this is step 1. Step 2. Step 1, here he splits, adds another blue point, splits again, splits again, splits again, splits again. I think that's working. Um, I'm concerned about why... Oh, it's because I resized the window and that fucks shit up. Okay, here we go. I think it's working. I think it's working. So now all we have to do is figure out how to color these things in. It's also a little weird to me that there's this one blue dot way the fuck up here. That seems kind of annoying. But we'll... That might just be a result of us looking at the way we're filtering these things. It could be that like the overall math thing is in the center, but most of his elements are not or something. So we might have to play with that a little bit. But let's figure out how to draw the fucking convex hull that we made. We should already be able to do that, right? It's just that we now need to make sure that the points are sorted in some way. So how do we do that? How do we do that? Do they talk about this in here? Add point C to the convex hull. Maybe not. Can we like sort? I mean, we can figure this out, right? We can think about this a little bit. We can just use our brains. So we have points in some arbitrary order. We pick one point, right? And I guess we want to... I find the thing with the... Like, closer is maybe good. Check A tan 2 from center, sort by angle. Yeah. That seems reasonable to me. I'm okay with that. I'm okay with that. So what? When we update the hull buffer, these come in arbitrary order. We sort their indices probably is probably the easiest way to do this. So we can do like index order is going to be like alloc points dot len number of u sizes, right? And then we say for 0 to points, for 0 to index order len I, we set like index order I to I, okay. Then we have to sort these things. So we sort them by like some context. So we say like std sort. We're sorting u sizes, right? Width of index order, okay, by some context, okay, which probably takes in like points equal points, right? And the lesson function. So can we just say sort ctx less? And then we could say like const sort ctx equals struct function less takes in, he needs some fucking signature, but what's fine. Points here is this, which is going to complain about shadowing. So I guess we kind of do like hull sort context here. Okay. And then this guy's going to be pissed because he wants this signature. So we just copy paste that signature here. Okay. Okay, hull sort CTX. And your suggestion was to use atan2s here. So we say points LHS is going to, we're going to be like, we're going to look at the L left and right, and we're going to return like stud math atan2 of A1, A0 if this is less than B1, B0. I'm okay with that. That seems like it'll probably do what we want, right? And then we iterate over index order. There. That's like a maybe. It's definitely a maybe. Fuck it. Let's just run it and see what happens. Oh, wait. We want these to be relative to the center of the thing. Right? Right? Because not the center of the world, otherwise the sorting wouldn't go clockwise. It would go like clockwise from the center of the screen, which is wrong. So maybe like this. Sure. I don't know, blaze it. I think that's working. Except for the fact that we're not making a convex hull. I think there's a problem where somehow an extra point is ending up in here. Right, like this looks like a hull. Why the fuck is the center in here? Right, what is happening here where like... No, that's definitely not doing the right thing, huh? Definitely not. So I would argue that the blue points here are at least like arguably correct, but the sorting of the blue points is not arguably correct. And then here we're forgetting to free index order. Okay. So what have we done wrong here? I feel like it feels right. I don't see why this wouldn't work. So we subtract the center. The center comes from the center of mass. 0.1. Center Y is not center X. Those are two different numbers. Okay. There's definitely something fucked up here. But now it might be doing the right thing. Almost. Almost. Let's look at the triangles. Okay, so first of all, who's drawing the blue dots, right? Who's drawing the blue dots? RGB. So it's got to be this, right? It's got to be the hull points here. Can we like not do any of the hull stuff and literally just draw elements that are part of the smath set? I want to make sure, like, have we accidentally thrown like a 0, 0 in there that we weren't supposed to? So can we literally just look at Smath points items here. Why the fuck did it just decide that it's time to rebuild ZLS? What the fuck? What changed? Oh, that's annoying. That's annoying. I can't even drink more coffee to make myself feel better. Damn. I guess we just have to wait it out. Or we can just not do that part. Because why the fuck? We don't need to build ZLS every time. We'll just delete that for now. That'll make our lives easier. Not relevant for today. Yeah, it's weird that like the hull points is starting to contain a 0, 0 point when when it's not here, right? So the hull points are somehow getting like corrupted. Right? Is kind of like the maybe corrupted is the wrong word. I'm getting ads in French, but I don't even speak French. Dude, I get that shit too. They think that like all of Canada speaks French. Fucking idiots. It's because sometimes the farthest point is invalid, so we should only do this at the split point. It's because we're adding an undefined point there that's probably just doing some dumb shit. That's my guess. Okay, so can we go back to rendering the hull points this way? And can we just run this thing to completion actually? While HF step. I don't want to do this like UI shit anymore where I'm pretty sure that he's doing the right thing to some extent. Okay, so now I think the hull is good, but definitely the polygon rendering is not good. Definitely we're missing some things in here. And it's probably because that wrapping that we were doing before, I just completely broke it without thinking about it. I'm just a dumbass. So it's because like here we're doing b is i+1. This is no longer true. So we need like index 0 to points len again. And this is like index, and then I is index order index. We'll call this like A index is this, and B index is this. Yes. And then here we use A index and B index. There we go. I forgot there's a level of indirection that we added that fucks our shit up. Much better! Let's go, dude! That's a fucking... Look at that. Look at that shit. Look at that shit. That is for sure drawing a box around some stuff. Look at that. Let's go. Okay. So what we might do with that thing, I don't know. Right? But at the very least, now we can draw a polygon that encloses a set of points, and that will maybe help us in some way, shape, or form down the line. It is 4 o'clock, so I was kind of gonna try doing some sort of like galaxy fragment shader shit, but given that it is past 4 o'clock, I think we call it there. But exciting stuff. Oops, didn't mean to open that. So we'll call it there. Thanks for watching, guys. I hope that was enjoyable. If you liked what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It is 4 o'clock Pacific time now. So you should expect to see us, if you're watching live, anytime between 3.5 hours ago and now. We are working on this code visualizer project right now. I am hoping that over time it will become a little bit more useful and interesting, but we have to move at the pace that we move at. If you want to keep track of this project, but you can't watch every day because, you know, you have a life, we have a YouTube channel linked in the Twitch description. The VODs for this are going into building a map of my code. There's a GitHub link in the Twitch description where the code for this will eventually end up under code map. If you're watching the VODs, you might go, these are only 2 hours. You said 4 hours. You said 3.5 hours. What up with that? It's because a lot of days we do this thing we call happy hour, which is just like, if we were to take our code and we left it the way we left it today, it wouldn't be very committable. So like if we were to do all the stuff that we don't do on stream, that's the kind of stuff that ends up in happy hour. It's like worth streaming, but not really like a new feature. It's like if you miss it, it's not important, right? But if you just want like the extra content to see us like working on like refactors and unit testing and like smaller, tweaks and stuff like that, you can hit the join button on YouTube, subscribe on Patreon, or subscribe on Twitch, and you will find the VODs in the appropriate places. Otherwise, plugging complete. YouTube, peace out. Twitch, let's find someone to raid.